Hotel quarters, enemy aircraft inbound.
Knowledge, skills, and abilities important to the Navy range from simple to highly complex. As situations become less well-defined, situation awareness, decision-making abilities, and communication skills become increasingly critical. A wide range of assessments exist for more routine procedural tasks and for fairly well-defined situations, and often rely on subjective human evaluators or generalized checklists. These approaches often lack adequate insight of why failure occurred. Not clearly understanding why an error occurred can result in the lack of appropriate remediation and the likelihood of reoccurrence of the error. In support of our collaboration with BBN Technologies, CRESST's goal is to develop an advanced and robust assessment methodology that addresses the need to understand why errors occur. CREST's approach uses observable data, what someone does or doesn't do, to make reliable judgments about why they did or didn't do it, and reliable predictions of the likelihood they will repeat the observed behavior. At the heart of CREST's solution is the use of Bayesian networks that model expert performance to accurately assess domain knowledge and skills, as well as the higher-level constructs of situation awareness, decision-making, communications, and ultimately, problem-solving ability. To support our research, we require simulations of complex tasks which capture rich datasets. To validate our ability to create such platforms, we developed a flooding simulation involving complex tasks and validated its utility at the Recruit Training Command, Great Lakes Naval Base, with the assistance of the Naval Services Training Command. We then partnered with the Center for Naval Engineering, CNE, at Norfolk, Virginia, to examine more complex scenarios. To support this research, CRESST built a prototype firefighting simulation and conducted usability studies with both CNE damage control instructors and a diverse population of CNE students. More recently, we developed two variations of a combined fire and flooding simulator, one with control over an entire repair locker team. We also worked with BBN Technologies to successfully demonstrate the ability to merge our Bayesian network approach with games and simulations created using diverse development platforms and languages by providing performance results from data extracted from their award-winning flooding game. With our recently signed Technology Transition Agreement with the Center for Naval Engineering, we are now working to determine a range of concepts, procedures, and scenarios most useful to damage control training and assessment, and at the same time, appropriate for CRESST research and development efforts. Meeting with leadership and instructors at CNE, along with the assessment and evaluation experts from ATG, CRESST has finalized its ontology for firefighting and is nearing completion of its ontology for flooding control. These ontologies hierarchically organize the knowledge, skills, and abilities related to each damage control domain. Using these ontologies, CRESST is modeling Bayesian networks to connect the components of the ontologies into a complex, linked structure with probability weightings. While it is important that CREST assessment methodology supports ATG scoring, CREST's main goal for reporting is the development of pioneering representations of performance that visually depict complex actions of individuals and teams. Using various event curves, we can graphically represent a wide range of scenario components and their interactions. With player curves, we can meaningfully represent what a player has done, when it was done, and the effect of the action on the player's health. Casualty curves represent the strength of the fire or flood casualty, when it was attacked, who attacked it, the result of the act, when it was extinguished, whether it reflashed or reoccurred, and when and if it was overhauled. There are resource curves for each damage control resource. These various team, casualty, and resource curves can be examined individually or overlaid to portray a complete picture of the damage control operation. By modifying the game to link game performance to in-game feedback and other forms of in-game assessment-based instruction, the damage control simulations become a robust training environment that can adapt to individual student needs. This type of system could support rating up, such as learning and practicing the skills needed to become a team leader, scene leader, investigator, repair locker leader, or damage control assistant. The same system could aid in the prevention of skill decay by offering a convenient, cost-effective, and variable practice environment. Because the assessment methodology involves the transfer of very little data between the simulation and the Bayesian network, it is well positioned for SCORM compliance and compatibility with a myriad of SCORM-based training applications. In partnership with the Center for Naval Engineering, CRESST will develop meaningful damage control simulations for use at the CNE Schoolhouse to enable us to further validate our Bayesian network approach to real-time and post-event assessment of trainee performance using computer-based simulations. During our R&D effort, we will add feedback components to examine the ability of our approach to accurately assess in-game performance and to provide appropriate and targeted remediation based on those assessments. We will partner with several ships to explore potential shipboard uses of CRESST assessment methodology.
So, by controlling the game, they'd be doing exactly what they'd be doing on the ship.
It would be a great indoctrination tool into damage control and going into their basic damage control qualifications and advanced.
You could also use it for personnel that are trying to get qualified, let's say investigator qualified.